Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. To convert propene, CH3CH is equal to CH2 into 1-propanol, CH3CH to CH2O, we need anti-Markovnikov addition of O to the terminal carbon, C1, of the double bond, with retention of the carbon skeleton. Moving on to the next step. 1-propanol is CH3CH to CH2O, where the O group is on the terminal, less substituted, carbon. This is the anti-Markovnikov product. Moving on to the next step. A. KMNO4, alkaline KMNO4 oxidize alkenes to diols, S1 the hydroxylthione, or, under vigorous conditions, cleaves the double bond giving carboxylic acids ketones. It does not give a monoalcohol product, it gives a 1,2-diol or oxidative cleavage products. Does not give 1-propanol. B. Osmium tetroxide, OSO4CH to Cl to OSO4 affects S1 the hydroxylthione of the double bond, converting CH3CH is equal to CH2 into a 1,2-diol, propane 1,2-diol, not 1-propanol. Does not give 1-propanol. C. B2H6, diborane, followed by alkaline H2O2, this is hydroboration oxidation. Diborane adds to the alkene in an anti-Markovnikov, SYN fashion, placing boron on the less hindered, terminal, carbon. Subsequent oxidation with alkaline H2O2 replaces boron with O with retention of configuration. For propene, this gives 1-propanol, O on C1. This is exactly the desired conversion. D. O3Zn, ozonolysis with Zn, reductive workup, cleaves the C is equal to C double bond to give two carbonyl compounds. For propene, this would give formaldehyde, HCHO, and acetaldehyde, CH3CH, not 1-propanol. The carbon skeleton is broken. And for the final step, only hydroboration oxidation, B2H6 followed by alkaline H2O2 achieves anti-Markovnikov addition of water across the double bond, yielding 1-propanol from propene without breaking the carbon chain or over-oxidizing. Therefore, the correct answer is C. Therefore, the correct answer is option C.